Hey Math 8, welcome to Chapter 6, Section 5. I am doing these notes because I think I did them fast in class or for people that are absent or what have you. So here we go. We're going to make a quick video of this section. So our goal in this section is that if I give you an equation, you can determine if it's linear or not. So that'd be one thing. And you can graph it. Those are the two things we want to be able to do. We want to be able to take an equation, immediately know whether it's linear or nonlinear, and be able to graph the equation on a coordinate plane. So let's get started. Here we go. You guys have spent a lot of time in this class solving equations. For instance, you have solved the equation x plus 2 equals 9. And I think everybody knows how to solve that. Of course, you get an answer. You get x equals 7, right? But that's an equation that has just one variable in it. We are now dealing in Chapter 6 with equations that have two variables. So no longer do you get a solution that's just one variable. The solution is an ordered pair. When you have an equation that has two variables, the solutions to the equation are ordered pairs that make the equation true. And one more thing, unlike this equation we did where we got x equals 7, and that's the answer, an equation that has two variables has infinitely many solutions, right? And we're going to look at that right now. So I have an equation here, and I'm going to make a little table of ordered pairs, right? One way to show ordered pairs is in a table. And I want to come up with ordered pairs that make this equation true, solutions to that equation. Now, some of you can probably just look at it and you can name the solutions. And others might have a little trouble with that. We've never done it before. Holy cow. It scared me. I'm going to close the window. There we go. Okay. So, a solution that makes it true. I claim if x equals 0, y would equal 1. And I can prove that that is an ordered pair that is a solution. If I put the 0 in for the y and the 1 in for the x, I would have 0 equals 5 times 1 plus 1. What have I done? I've done it wrong. That's what I've done. I would have 0. Let me try this again. If I put 0 in for x and 1 in for y, I would have 1 equals 5 times 0 plus 1. Is that true? Well, 5 times 0 is 0, and 0 plus 1 is 1. It is true. That is an ordered pair that is a solution to that equation. But I claim there's many more, all right? There's infinitely many, in fact. If I put 2 in for x, y would be 11, because 5 times 2 is 10, and 10 plus 1 is 11. If I put 10 in for x, y would be 51, because 5 times 10 is 50, plus 1 is 51. These are just 3 ordered pairs that are solutions to that equation. Now, here's the thing. When y is by itself, I think it's pretty easy to come up with solutions. You can just pick anything you want for x, like say 10, and you can say, all right, 5 times 10, that's 50 plus 1. Y is 51. Pretty easy when the y is by itself. But example B, not so easy. When the y is not by itself, it's not as easy to come up with ordered pairs, but we can still do it, and it's not that hard. So the way you would do it is you would pick a value for x, like say 1, and you would substitute that in for x. So I would say 3 times 1 plus 2y equals 12, or 3 times 1 is 3, so 2y plus 3 plus 2y equals 12. And now I can solve for y. I can figure out what y value makes this true when I put 1 in for x. I can subtract 3 from both sides, giving me 2y equals 9. I can divide by 2, and I get y equals 4.5. When x equals 1, y would need to be 4.5. 3 times 1 plus 2 times 4.5 equals 12. It's true. And I could find more of these the same way. Maybe I'll do one more. So let's do one in red. What if x were, I don't know, what if x were 6? It will not let me change colors. All right, so I'm going to put 6 in for x. Plus 2y equals 12. That'd be 18 plus 2y equals 12. And I would subtract 18 from both sides. And I would get 2y equals negative 6. And divide by 2 and get y equals negative 3. And I have found another ordered pair. All right, do you see how I'm just substituting a number in for x, and I am solving for the y value that corresponds to that x value? All right, so here's the main thing we want to be able to do. We want to be able to graph an equation on a coordinate plane. And to do this, we need to learn how to set up a table. So, how do we set up a table? All right? We set up a table by, first, some people just draw like a T-chart. I have included tables on here for you, but if I did not include tables, you could just make a little T-chart like that. And you may select any x value you want. And you just fill them into the table, and then you, after you fill them in one at a time, substitute each x value into the equation and solve to find the corresponding y value. All right, let's try 1 or 2. So in this first one, I get to pick any x values I want. Maybe I'll just pick 4 small ones like 0, 1, 2, 3, and 4. And then one at a time, I substitute these in for x. Maybe you can just do this in your head. So in this case, y would equal negative 2 times 0 plus 7. That'd be 0 plus 7. That'd be 7. Y would equal 7. And if I put 1 in for x, y would equal negative 2 times 1 plus 7. Well, that'd be negative 2 plus 7. That'd be 5. And I hope you get the idea. Then I would get 3, and I would get 1, and I would get negative 1. All right? That is one way to make, well, that's the way to make a table. Let's try a harder one. For this one, let's try negative 2, negative 1, 0, 1, and 2. I want you to see something here. So I start with the negative 2, and I put it in for x. Y would equal negative 2 squared plus 1. Now, this is the biggest thing that people mess up, the negative 2 squared. When you do this on your calculator, if you don't type it in right, it tells you the answer is negative 4. But it's not negative 4, it's positive 4. when you put it in your calculator, if you're going to use a calculator, you must put parentheses on it before you square it. And 4 plus 1 is 5. So when I put -2 in for x, I get 5 for y. And then I would go to -1. And I would get -1 squared plus 1. And that would equal, let's see, -1 squared is +1, and 1 plus 1 is 2. And I could let you do the rest. I'm just going to give them to you. This would be 1. And if I put 1 in, I would get 2. And if I put 2 in, I would get 5. Look at that, how it's kind of symmetrical. Interesting. All right. So what I'm hoping is if I give you an equation, you now know how to make a table from the equation. All right. Here is a big topic right here. This is one of our main topics. How can we tell before we make the table if the equation is linear or nonlinear? And there's just 2 rules to learn here. Linear equations will not have any exponents on the variables. And they will not have the variables multiplied together. So if you have an equation that says something like y equals x squared plus 1, there's an exponent. It is not going to be linear. Or if you have something like xy equals 10, so the variables are multiplied together. Not linear, right? Linear means when you graph it, it will not make a straight line. But if it is linear, it will make a straight line. All right, so here's what we want to be able to do. This is the final thing. When you graph an equation, we want to be able to graph an equation. And I feel like there are 3 steps here to doing that. First step, very easy. Determine if it will be linear or nonlinear. And that's important because we can save some time. We are going to need only 3 ordered pairs to make a graph if it's linear. But if it's nonlinear, we need 5 ordered pairs. All right, that's step 1. Just decide linear or nonlinear. Step 2, make a table of ordered pairs. Right? We just practiced doing that back here in example 1. Make a table of ordered pairs. Now, you may pick any x values you want, but I have told you on the homework, for linear, I want these to be your x values. And for nonlinear, I want these to be your x values every time right now. All right, so step 2 is make a table. And then finally, step 3, once you have the table, plot them on a coordinate plane and connect them with a line or a curve. Let's do an example or 2 and we'll be done. All right. So step 1 is decide if it's linear or nonlinear. This one is linear because it has no exponents and it does not have the x and y multiplied together. So because it's linear, I only need 3 ordered pairs. So I'm going to cross out these last 2. And I'm going to pick 0, 1, and 2. All right? And I'm going to figure out the y value. So I'm going to put 0 in for x. And that would give me y equals 0 minus, that'd be -5. And then I'm going to put 1 in for x. So y would equal 3 times 1 minus 5. That'd be 3 minus 5, that'd be -2. And I'm going to put 2 in for x. So y equals 3 times 2 minus 5, that's 6 minus 5, that's 1. So step 2, I have made the table. And then step 3 is to graph it. 0, -5 right here. 1, negative 2 would be right here, and 2, 1 would be right here. And I connect those with a nice line, and this line represents this equation. We'll talk more about that next time. I want to do one more because this gives people trouble. So this is an example of one that is nonlinear because it has an exponent. So I have to do all 5 points like this. So I'm going to start at negative 2, and I'm going to substitute it in and get the y value. Negative 2 squared minus 5. That'd be 4 minus 5. That'd be negative 1. Then I'm going to take negative 1. I'm going to substitute it in. That'd be negative 1 squared minus 5. That'd be 1 minus 5. That'd be negative 4. And then I'm going to put 0 in. So y would equal 0 squared minus 5. That'd be negative 5. Then I'm going to put 1 in. Y would equal 1 squared minus 5. That would be 1 minus 5. That'd be negative 4. And finally, I'm going to put 2 in. Y equals 2 squared minus 5. That would be 4 minus 5, or negative 1. All right, so I made the table. I just want you to see the graph. So the first point is at negative 2, negative 1, right there. Then I'm at negative 1, negative 4. Then I'm at 0, negative 5. Then I'm at 1, negative 4. And then I'm at 2, negative 1. My graph is kind of a U-shaped graph. It looks like this. That graph is called a parabola. All right. Good luck on the graphs. I will see you in class next time.